Hello everyone, this is Bhukya Krishna, rule number 20951A2130, branch aeronautical engineering. So today I want to discuss about Cauchy-Lenoir's theorems and its applications. Introduction. Castiglione's method, named after Carlo Alberto Castigliano, is a method for determining the displacements of a linear elastic system based on the partial derivatives of the energy. So this method is named as after Carlo Alberto Castigliano, and it is used to determine the displacements of linear elastic system based on partial derivatives of the energy. He is known for his two theorems. So there are two theorems. The basic concept may be easy to understand by recalling that a change in energy is equal to the causing force times the resulting displacement. Therefore, the causing force is equal to the change in energy divided by the resulting displacement. Alternatively, the resulting displacement is equal to the change in energy divided by the causing force. Partial derivatives are needed to relate causing forces and resulting displacement to the change in energy. Castigliano's first theorem. The first partial derivative of the total energy, internal energy, that is energy, in a structure with respect to any particular deflection component at the point is equal to the force applied at that point and in the direction corresponding to that deflection component, that is du by duj is equal to pj. So Cauchy-Riemann first theorem tells about the first particle derivative of the total energy in a structure with respect to deflection component at the point is equal to the force applied at that point in the direction of corresponding deflection component. This is the Castiglione's first theorem. Here we can discuss about the Castiglione's second theorem. The first partial derivative of the total internal energy in a structure with respect to the force applied at any point is equal to the deflection at the point of application of that force in the direction of its line of action. The second theorem of Castiglione is applicable to linearly elastic structures with constant temperature and unyielding supports. Note that in the above statement, force may mean point force or a couple moment, and displacement may be mean the angular rotation. Du by dpn is equal to un. So Casimir's second theorem tells about the first partial derivative of the strain energy, that is called as also total energy in the structure with respect to the force applied at any point is equal to the deflection at the point of application of that force in the direction of its line of action. So these are the conditions we should have. We should take a beam is gradually loaded with the 3-point loads, that is P1, P2, P3. Here the beam AB carrying the loads P1, P2, P3 and deflection delta 1, delta 2, delta 3. The distance between A and B is L. And the additional condition that a small load is added to the beam at point 1. So the load is applied to beam at point 1, that is P1 plus dP1. That is the load 1 and P2 is the load 2 and P3 is the load 3, and deflection delta 1, delta 2 and delta 3. These are the deflections. So work W equal to of P1 delta 1 plus of P2 delta 2 plus of P3 delta 3. This is the additional condition load. So the applications of Castiglione's two theorems are given below. Castigliano's first theorem is being used in structural analysis for finding deflection of an elastic structure based on the strain energy of the structure. So it is being used to structural analysis for finding deflection of an elastic structure based on strain energy of the structure. And the Castiglione's theorem can be applied when the supports of the structure are unyielded and the temperature of the structure is constant. The second theorem of the Castigliano is applicable to linearly elastic Hookean material structures with constant temperature and unyielded supports. Note that in the above statements, force may mean point force or coupled moment, and the displacement mean translation or angular rotation. Castigliano's first theorem is being used in structural analysis for finding deflection of an electric structure based on strain energy of the structure. Thank you.